Let's use a trig substitution to help us evaluate this integral. Start by recognizing that we're looking at the form variable squared minus a constant squared. In that case, we use the substitution x equals a secant theta, where a in this case is 5. Then dx would be 5 secant theta tangent theta. D theta. So we'll rewrite that integral now and replace the x's with 5 secant theta. We have 5 secant theta squared minus 25 all divided by 5 secant theta. And then dx we're actually replacing with 5 secant theta tangent theta d theta. At this point we can simplify a tiny bit. We have secant theta in the numerator and denominator, and we have 5 in the numerator and denominator. So let's get rid of those. Simplifying under the radical, we can get 25 secant squared theta minus 25, and then we still have tangent theta d theta. Remember, our ultimate goal is to have a perfect square under the radical, so let's start by simplifying that. We'll factor out a 25, leaving us with secant squared theta minus 1. Copy tan theta d theta. Now we have the square root of 25, and we'll use a trig identity to replace secant squared theta minus 1. Recall that that is really just tangent squared theta. We'll copy tan theta d theta. At this point we have a perfect square under the radical now, so we can rewrite that. Square root of 25 is 5. Square root of tangent squared is tangent. We have 2 tangents there, so that is tangent squared theta d theta. Let's pull the 5 outside the integral, and tangent squared will go back to the trig substitution that we used earlier and replace tangent squared with secant squared theta minus 1. At this point we can break apart that integral. We'll have the integral of secant squared theta d theta minus 5 times the integral of 1 d theta. The integral of secant squared theta is tangent theta. Then we have minus the integral of 1 is simply theta, and we want to not forget plus c. At this point, let's go back to that substitution that we used at the beginning. X equals 5 secant theta. Let's divide both sides by 5. We're going to use this to help us set up a triangle. Recall the saying "so katoa" from back in trig. That will help us set up this triangle. We'll have theta here, and we're given that secant is x divided by 5. Cosine, recall, is adjacent over hypotenuse, and it's just the reciprocal of secant. So if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. That is x over 5, which means we now need to find this missing side. We can find it using the Pythagorean theorem. We'll simply get the hypotenuse squared minus the side squared. 5 squared is 25. Now we'll come back up here. Tangent is opposite over adjacent. So we have opposite will be that number we just found, square root x squared minus 25, divided by the adjacent side, which is 5. Then we have minus 5 times theta. To find theta, we're not going to use a triangle. We're going to use this rule from earlier. X divided by 5 is equal to secant theta. To isolate theta, we can take the arc secant of both sides. Remember, the arc secant of secant is simply theta. So theta is equal to the arc secant of x divided by 5. So we have 5 times the arc secant of x divided by 5. Then all of that is still plus c. We can simplify a little bit. We can reduce those 5's in the first term, leaving us with x squared minus 25 under the radical minus 5 arc secant of x divided by 5 plus c.